Imagine a single python farm in Southeast Asia housing over 3 million serpents in climate-controlled facilities that stretch across hundreds of acres, producing more than 50,000 premium leather hides annually worth over $20 million in international luxury markets. Right now, across specialized facilities from Vietnam to Indonesia, millions of pythons are being raised in sophisticated operations that transform these powerful predators into some of the world's most coveted leather goods and traditional medicine ingredients. These industrial-scale farms can process over 15,000 pythons daily, using cutting-edge technology that maximizes hide quality, while maintaining strict standards for both animal welfare and worker safety. But how do you manage millions of carnivorous reptiles that can grow 20 feet long and weigh over 200 pounds? What revolutionary farming techniques enable commercial-scale python production in controlled environments designed for maximum efficiency and safety? How has an industry rooted in ancient traditions evolved into a billion-dollar global enterprise serving luxury fashion houses and traditional medicine markets worldwide? Welcome to AgriCraft, where we explore the most extraordinary developments in alternative agriculture and exotic livestock production. Today, we're taking you inside the remarkable world of commercial python farming, from breeding facilities to processing plants that create some of the most expensive leather products on Earth. All will be revealed in this video. The evolution of python farming from traditional hunting practices to modern industrial agriculture represents one of the most dramatic transformations in exotic livestock production. For centuries, python hunting in Southeast Asia provided local communities with valuable leather and meat, while supplying traditional medicine practitioners with essential ingredients for treatments that remain popular across Asia today. These traditional practices established the foundation for understanding python biology and behavior that would later enable large-scale commercial production. The modern python farming industry emerged in the 1970s as entrepreneurs in Vietnam and Thailand began developing controlled breeding programs to meet growing international demand for python leather from luxury goods manufacturers. Early pioneers discovered that pythons offered several unique advantages over conventional livestock, including exceptional hide quality, minimal space requirements per animal, and the ability to convert relatively small amounts of feed into valuable products through their naturally slow metabolism. Commercial python farming gained significant momentum during the 1980s and 90s, as international fashion houses began incorporating exotic python leather into high-end handbags, shoes, and accessories that commanded premium prices in global luxury markets. The distinctive diamond-patterned scales and natural flexibility of python leather made it particularly prized by designers seeking materials that combined beauty with durability for exclusive products. Today, the global python farming industry generates over $2 billion annually, with Vietnam leading world production at approximately 8 million pythons processed yearly. Indonesia follows with significant operations producing over 3 million pythons annually, while Thailand and Malaysia maintain substantial facilities serving both domestic and export markets. The industry processes an estimated 15 million pythons globally each year, supplying luxury leather manufacturers and traditional medicine producers worldwide. What makes commercial python farming so compelling to agricultural entrepreneurs is the remarkable efficiency these reptiles demonstrate in converting feed into valuable products. Adult pythons require feeding only once every 2 to 4 weeks due to their extremely slow metabolism, dramatically reducing feed costs compared to conventional livestock. A single python hide can sell for hundreds of dollars in luxury leather markets, making python farming one of the most profitable forms of exotic agriculture per square foot of facility space. The foundation of commercial python farming begins with sophisticated breeding programs that maintain genetic diversity, while selecting for traits like rapid growth, hide quality, and reproductive success. Professional python breeders maintain breeding colonies in specialized facilities, featuring climate-controlled environments that replicate optimal tropical conditions year-round. These breeding facilities utilize advanced environmental control systems that can maintain precise temperature and humidity ranges regardless of external weather conditions. Female pythons reach sexual maturity at approximately 3 to 5 years of age and can produce clutches of 20 to 100 eggs annually under optimal commercial conditions. The breeding process requires careful management of environmental conditions that trigger natural mating behaviors, including specific temperature cycling and spatial arrangements that encourage successful reproduction. Professional breeders utilize decades of experience combined with modern monitoring technology, to optimize breeding success rates. Egg incubation represents the most critical phase, determining the success of commercial python production. Fresh python eggs are carefully collected and transferred to specialized incubation facilities that maintain precise temperature and humidity conditions for the 60 to 90-day incubation period. Industrial incubation systems can handle thousands of eggs simultaneously, while maintaining the consistent environmental conditions required for high hatch rates and healthy offspring. The incubation substrate consists of specially prepared mixtures of vermiculite, peat moss, and moisture-retaining materials that provide optimal conditions for developing embryos. This substrate undergoes continuous monitoring and adjustment to maintain moisture levels within narrow ranges that ensure successful development. Temperature control during incubation must remain within 1 degree of optimal ranges, as even minor variations can significantly affect hatch rates and offspring viability. Newly hatched pythons measure approximately 12 to 18 inches in length and require intensive care during their first months of life. Juvenile pythons are housed in climate-controlled nursery facilities with individual containers that prevent cannibalism while providing optimal growing conditions. These nursery facilities feature automated heating systems and environmental controls that ensure consistent conditions for thousands of young pythons simultaneously. The feeding program for juvenile pythons utilizes specially sourced prey animals including mice, rats, and chicks that provide optimal nutrition for rapid growth and healthy development. Early nutrition plays a critical role in determining adult size, hide quality, and overall health throughout the production cycle. Professional python farmers work with nutritionists and veterinarians to develop feeding programs that maximize growth rates while maintaining animal health and hide quality. As pythons mature, they transition to larger growing facilities that provide the space and environmental conditions needed for continued development toward processing size. Adult growing facilities feature climate-controlled buildings with individual enclosures designed to prevent fighting while enabling efficient feeding and monitoring operations. These facilities utilize specialized containment systems designed specifically for python management, ensuring both animal welfare and worker safety. Environmental management in commercial python facilities requires sophisticated understanding of reptile physiology and behavior patterns. Pythons are ectothermic reptiles that rely on external heat sources to regulate body temperature and metabolic function, necessitating heating systems and thermal gradients that enable optimal physiological processes. These facilities incorporate industrial heating systems, backup power supplies, and monitoring equipment that maintain optimal temperatures continuously. The feeding regimen for growing pythons consists of regular meals of appropriately sized prey animals delivered on schedules that optimize growth while minimizing stress and competition. Modern python farms often integrate with poultry and small livestock operations, utilizing surplus animals and processing byproducts as cost-effective feed sources. This integration creates sustainable agricultural systems that minimize waste while reducing feed costs for python operations. Automated feeding systems and monitoring technology enable efficient management of thousands of individual pythons while maintaining detailed records of growth rates, feeding schedules, and health status for each animal. These management systems incorporate identification technology and database systems that track individual animals from hatching through processing, ensuring optimal production outcomes and regulatory compliance. When pythons reach optimal processing size after approximately 18 to 30 months of intensive cultivation, they enter the harvest phase of commercial production. This timing represents the balance between maximum hide size and optimal hide quality, as younger animals produce more flexible leather while older animals develop larger but potentially tougher hides. Professional python farmers utilize established protocols that ensure harvest timing maximizes the value of each production cycle. The harvest process requires specialized handling techniques and safety equipment developed specifically for python management, as these powerful constrictors possess sufficient strength to seriously injure handlers if not properly managed. Professional handlers utilize protective equipment, restraint devices, and specific techniques that ensure both animal welfare and worker safety during harvest operations. The handling procedures reflect decades of experience in commercial reptile management and strict safety protocols. Transportation from growing facilities to processing plants utilizes specialized vehicles designed for live python transport with secure containment systems and climate control that maintains optimal temperatures during transit. These vehicles feature reinforced compartments and monitoring systems that ensure animals arrive at processing facilities in optimal condition for high-quality hide production. The transportation logistics coordinate with processing schedules to minimize stress and maintain product quality. Processing facilities for pythons incorporate specialized equipment and safety systems designed specifically for handling large, powerful reptiles throughout all processing stages. These processing plants feature automated handling systems adapted from conventional meat processing technology, but extensively modified for the unique requirements of python anatomy and hide characteristics. The facilities maintain strict safety protocols and environmental controls throughout all operations. The initial processing steps involve humane stunning procedures that ensure immediate unconsciousness while preserving hide quality and worker safety. This is followed by precise cutting techniques that maximize hide yield while maintaining the integrity and pattern consistency that luxury leather manufacturers demand. Skilled processors must understand python anatomy thoroughly, as proper technique significantly affects both hide quality and processing efficiency. Industrial processing machines specifically designed for python handling move carcasses through automated systems that remove hides with precision cutting that preserves the distinctive scale patterns and natural flexibility that make python leather so valuable. The hide removal process requires specialized equipment that maintains consistent thickness and avoids damage that could reduce leather quality or market value. Temperature control throughout the processing facility maintains optimal conditions for hide preservation and processing safety. Refrigeration systems maintain processing areas at precisely controlled temperatures that prevent deterioration while preserving the natural characteristics that make python leather superior to synthetic alternatives. The temperature control systems incorporate monitoring technology that tracks conditions throughout all processing stages. Quality inspection procedures at multiple stages ensure that only premium hides reach luxury leather manufacturers. Trained inspectors examine each hide for defects, damage, or processing errors that could affect final leather quality or market value. This inspection process follows strict grading standards developed specifically for python leather, with documentation requirements that track each hide from farm to final customer. The hide processing continues with preliminary treatment procedures that prepare raw python hides for tanning operations at specialized leather processing facilities. These preliminary treatments include cleaning, preservation, and initial chemical treatments that prevent deterioration during storage and transportation to tanning facilities. The preliminary processing ensures optimal hide condition for subsequent leather manufacturing operations. Computer-controlled grading systems sort python hides by size, pattern quality, and condition characteristics that determine their suitability for different luxury leather applications. Premium-grade hides destined for high-end handbags and accessories undergo more rigorous inspection than those intended for smaller leather goods or industrial applications. This grading process ensures optimal utilization of valuable raw materials while meeting specific customer requirements. The leather processing component represents specialized industrial procedures that transform raw python hides into finished luxury materials through complex tanning and finishing operations. Python leather processing requires unique techniques that preserve the natural scale pattern, while creating the flexibility and durability that luxury goods manufacturers require. These tanning operations utilize specialized chemicals and equipment designed specifically for exotic leather processing. Industrial tanning processes for python leather involve multiple stages of chemical treatment, mechanical processing, and quality control that can extend over several weeks. The complex tanning procedures utilize computer-controlled systems that ensure consistent treatment while preserving the distinctive characteristics that make python leather command premium prices in luxury markets. These tanning facilities represent significant technological investments that enable consistent quality across large production volumes. Automated packaging systems handle the diverse range of python products while maintaining the precision and cleanliness required for luxury applications. Specialized packaging protects finished python leather during storage and transportation, while maintaining the quality standards that luxury manufacturers demand. The packaging process includes detailed labeling that provides traceability information and quality certifications required by luxury goods manufacturers. Different packaging specifications serve leather manufacturers, traditional medicine producers, and specialty markets, with climate-controlled packaging materials designed to maintain product quality during extended storage and international shipping periods. The packaging lines incorporate quality control checkpoints and documentation systems that ensure consistency and regulatory compliance across all product categories. Distribution networks for Python products serve global luxury markets through specialized supply chains adapted for high-value exotic materials. Climate-controlled storage and transportation maintain optimal conditions for Python leather, while providing the security and handling procedures required for valuable luxury materials. The distribution systems incorporate tracking technology and insurance coverage that protect valuable shipments throughout international logistics networks. International shipping logistics coordinate between processing facilities, specialized leather manufacturers, and luxury goods producers worldwide. The distribution channels include direct sales to established leather manufacturers, specialty traders, and traditional medicine distributors who serve diverse global markets. These distribution networks require expertise in international trade regulations and customs procedures for exotic animal products. Storage facilities maintain climate-controlled environments, specifically designed for Python leather preservation while providing the security and inventory management systems required for high-value luxury materials. These storage systems employ monitoring technology that tracks environmental conditions and provides real-time alerts for any deviations that could affect product quality or value. The comprehensive utilization of Python biomass extends beyond primary leather products to include traditional medicine applications and specialized byproducts that maximize economic returns from each animal processed. Python bile, blood, and organs command significant prices in traditional medicine markets throughout Asia, where these materials are valued for their perceived medicinal properties and traditional healing applications. Traditional medicine processing requires specialized facilities and procedures that maintain product purity and potency while meeting regulatory requirements for medicinal products. These processing operations utilize traditional methods combined with modern quality control procedures that ensure consistent products for traditional medicine practitioners and consumers. The traditional medicine applications represent substantial additional revenue streams that improve overall production economics. Rendered Python fat and oil find applications in traditional medicine and specialty cosmetic products, requiring specialized extraction and purification procedures that create pharmaceutical-grade materials. These byproduct processing operations utilize modern extraction technology while maintaining the traditional characteristics that consumers expect from authentic Python-derived products. The cultural significance of Python products in traditional medicine continues driving substantial demand throughout Asia, where Python-derived treatments remain popular for various health conditions. Traditional practitioners value Python products for their perceived strength-enhancing and healing properties, creating consistent market demand that supports commercial Python farming operations. These traditional applications represent important cultural practices that have sustained Python utilization for centuries. Modern Python farming must navigate complex regulatory environments that govern both exotic animal production and international trade in Python products. The Convention on International Trade in Endangered Species regulates Python trade to ensure sustainable harvesting and prevent exploitation of wild populations. Commercial Python farms must maintain detailed records and comply with international monitoring requirements that ensure legal and sustainable production. Environmental considerations surrounding commercial Python farming reveal both challenges and opportunities for sustainable exotic agriculture. Python farming can reduce pressure on wild populations, while providing economic alternatives to habitat destruction in tropical regions. However, Python farming requires careful waste management and biosecurity measures that prevent environmental contamination or disease transmission to wild populations. Sustainability efforts within the Python farming industry include development of closed-loop production systems that minimize waste while maximizing resource efficiency. These initiatives incorporate renewable energy systems, water recycling technology, and integrated waste management that reduces environmental impact while improving production economics. The sustainability measures position Python farming as responsible exotic agriculture that balances economic opportunities with environmental stewardship. The biosecurity requirements for Python farming facilities include disease prevention protocols and quarantine procedures that protect both farmed animals and wild populations from disease transmission. These biosecurity measures utilize veterinary expertise and monitoring systems that ensure healthy production while preventing ecological risks associated with exotic animal farming. The remarkable journey from python egg to luxury leather products demonstrates how traditional practices can evolve into sophisticated agricultural industries that serve global markets while preserving cultural traditions. Modern python farming combines understanding of reptile biology with industrial technology to create efficient production systems that deliver consistent quality products to demanding luxury markets. The scalability of python farming operations enables expansion to meet growing market demand while maintaining the quality standards that luxury manufacturers require. Individual facilities can house hundreds of thousands of pythons while maintaining the careful management and quality control that premium markets demand. This scalability enables industry growth while preserving the artisanal characteristics that differentiate python products from mass-produced alternatives. Technological advancement continues improving production efficiency and hide quality, while reducing costs and enhancing worker safety in python farming operations. Automation systems, environmental controls, and processing equipment specifically designed for python farming enable increasingly sophisticated operations that achieve consistent results while minimizing risks associated with handling dangerous reptiles. The integration of python farming with sustainable agriculture systems creates opportunities for rural development and economic diversification in tropical regions where conventional agriculture faces limitations. Python farming can provide valuable income streams for rural communities while utilizing existing agricultural infrastructure and expertise. This integration demonstrates how exotic agriculture can complement rather than compete with traditional farming systems. As global demand for luxury leather goods continues growing and traditional medicine markets expand, python farming represents a proven agricultural model that addresses multiple market demands through innovative production systems. The combination of exceptional product quality, cultural significance, and economic viability creates compelling opportunities for agricultural entrepreneurs seeking alternatives to conventional livestock production. Thank you for joining us on this extraordinary exploration of commercial python farming, where ancient traditions meet modern agriculture technology to create sophisticated industries serving global luxury markets. The complexity and potential of this industry demonstrate the incredible innovation happening in exotic agriculture, creating opportunities for farmers while preserving important cultural practices and meeting growing demand for sustainable luxury materials. If you found this behind-the-scenes look at python farming as fascinating as we did, please give this video a like and subscribe to AgriCraft for more incredible stories from the world of alternative agriculture and exotic livestock production. What other unconventional farming enterprises would you like us to investigate? Share your thoughts in the comments below, and we'll continue exploring the remarkable agricultural innovations that are redefining what modern farming can achieve while serving unique global markets.